So now in this video, we're going to look at using the RC time constant while a capacitor is charging and discharging. We're going to use the same value resistors, so we should have the same curve except for one going up and then one going down. And so I have here a 1000 ohm resistor going to the top of that switch connected, the bottom of that switch connected to the top of that switch. Remember, they're always connected on bottom and always connected on top. They're separated top to bottom. And then so the top of this switch is connected to the bottom of that one, and then the bottom of this switch is a resistor to the negative rail over there. And we will add the capacitor. There you can see a little better. It's a 1000 microfarad capacitor. We can charge it up to 35 volts. That side has to be more positive. I forgot to mention that in the last video. So I can put this anywhere. This is a direct connection. Those 2 points, I can put it up here and go to the negative rail, or I can go down here and connect it to the negative rail. So I'm just going to put it down there, and again, doesn't really matter. So now we are going to grab the oscilloscope here and look at the waveform that we get, which of course is the RC time constant. So the black alligator clip, I just clipped it to a wire here. I'm going to put this wire to the negative rail, and we got the red alligator clip there. That's coming from the oscilloscope there. We're going to put it to the capacitor so we can monitor the voltage of the capacitor. And there you can see it leveled off because we don't have all this noise anymore. Now it's actually looking at the capacitor voltage. And so I'm going to charge it up. I have the power supply set to 7 volts because we have 8 squares here, and so we can easily see up to 7. So I'll try to pause it right when we get there. Since it's a 1000 microfarad capacitor, 1/1000th of a farad, and we have 1000 ohm resistor, that's 1000 ohms, so 1000 times 1000th is 1 second. That's how long it takes to get about 2/3 of the charge. As you can see there, we're about 2/3 of the way. And then the next second's another 2/3, and so on. We went over this in the last video. And we consider 1, 2, 3, 4, 5 time constants as fully charged. There you can see it may change a tiny bit, but for the most part, we've fully charged it. And so now, that was the charge, and when I press this, it's going to clear and then jump right up there. And so now it's charged. It's holding that charge, and these capacitors, they kind of lose charge over time unless they're very low voltage. They may hold like a volt or two, but 7 volts over time, it's going to slowly kind of trickle down. We can top it off if we want right there. And so it's going to hold that a bit, slowly go down. Now we are going to hit this button and discharge it through a resistor. And there you can see we have the same curve, but in the opposite direction, right there. And now I don't need to hold it anymore. I'll try to stop it right when it gets to a square, and I did pretty good right there. Again, same curve. We did the same process except for we discharged it. So all the power that went through the resistor was provided by the capacitor. And so there's a 1 time constant. That's about 2/3 of the way discharged. And then about 2/3 closer, 2/3 closer, so on. After 5, as I said before, 1, 2, 3, 4, 5, we consider it fully discharged. So now we added a couple LEDs in series with the resistors so that we can see them light up as the capacitor charges and discharges, and we'll see a problem with that, and because of their voltage blocking. And so, in any case, we're not right at 0 volts anymore, and we got some noise too that it's picking up, but that is probably because capacitors, these electrolytic ones, the way that they are made, when you completely discharge them, they gain some of the voltage back just naturally. And so they don't like recharge themselves or anything, but they kind of recharge themselves a little bit. So they have a little bit of voltage. But in any case, now we're going to look at the curve going through an LED. So it's still a 7 volt power supply right there. And there you can see we're up 1, 2, 3, 4, about 5. So with a very little current going, it's blocking about 2 volts. And then when we discharge it, we're going to fall eventually to only about 2 volts above the 0 volt down there. So we got some noise there. My finger's kind of touching it, but in any case, there you can see that we're 2 volts of the rail. That's because the diodes take a couple volts before they will conduct, and then they block that voltage from everything else. So now that's it for this video. As you can see, we have the schematic there. There's the capacitor to charge when we press that button, and then discharge when we press that button. I put a little blue line there. That's when we press that blue switch right there that I just colored in blue. Hopefully you can see that. And then red. I put a red switch when you press that one, it discharges. If you just hold them, then current will flow through the two of them. The capacitor will sit at half of the power supply voltage after it charges or discharges to that point. But in any case, I'm trying to keep these videos short. This one ran longer than I wanted, but in any case, check out these other videos. Make sure you subscribe too if you haven't, and click the bell so you see all my videos. But as always, thanks for watching. I will see you in the next video.